Hi everyone, my name is Anna Mavrogianni. I am an associate professor in sustainable building and urban design at the Institute for Environmental Design and Engineering, or ID for short, at the Bartlett at UCL. A warm welcome to everyone who has joined our session today, as well as the panel of our excellent speakers. So this is the first webinar in our series of integrated building design webinars. So I would first like to say a few words to introduce ID. Oops. Don't know what happened there. Oops. There we are. So apologies for this. So yeah, just a few words to introduce ID. So we are celebrating a century of the Bartlett and 55 years of environmental design and engineering at the Bartlett. We at ID, we pursue a deeper understanding of the interactions between the built environment and the 24th century challenges: human health, well-being, productivity, energy use, carbon emissions, and climate change, as well as inequalities. And we are part of the Bartlett, UCL's global faculty of the built environment. We're a very vibrant community of academics, researchers, PhD, postgraduate and undergraduate students. And our academic excellence is recognized through a number of awards and through the Research Excellence Framework. And in 2020, we are third in the world for architecture and the built environment. We have a number of taught programs, both undergraduate and postgraduate. So at the postgraduate level, the established MSc in Environmental Design and Engineering adopts an interdisciplinary and holistic approach to energy and carbon. The MSc in Light and Lighting focuses on creative and technical advanced lighting design and controls. The recently launched MSc in Health, Wellbeing and Sustainable Buildings, of which I'm a Deputy Program Director, looks at design and management for health and wellbeing at building and city scale. And another new program is the MSc in Smart Buildings and Digital Engineering that looks at building systems, engineering and integration. And of course, we have the 4-year undergraduate degree in the MNs in Engineering and Architecture Design, which really pioneers integrated architecture, environmental and structural design. So without further ado, I would now like to introduce this talk, just to remind our audience that this session is recorded. So I would just like to say a few words about our first session in this series. So in our first seminar today, we have speakers from Hawkins Brown and Buro Happold. We will discuss working on the 22 Gordon Street building. This building was redeveloped from the old Wates House, creating a new home for the Bartlett faculty and the Bartlett School of Architecture. Their talk will describe the need for the project and how the brief was finalized, the collaborative design development, design solution, and the post-occupancy analysis findings. So, as I said, we have 3 speakers with us today. First, Ewan MacDonald. He's an architect and partner at Hawkins Brown. Since joining Hawkins Brown, Ewan has contributed towards a diverse portfolio of projects covering the residential, education, and commercial sectors. More recently, he has developed a particular interest in civic buildings and the search for creative responses to the diverse needs of their communities. He has led the delivery stages of one of the practice's largest projects, the award-winning Corby Cube. We have with us also Kenichi Hamada. Kenichi is an associate in the building services team in Buro Happold. He's a chartered engineer and a member of SIPSI. His project experience expands from London office floor fit out to overseas high-speed rail stations. He was a technical services manager for the 2012 London Olympic and Paralympic Games. Kenichi leads the modernization and refurbishment sector of the Building Asset Repurposing Group within Buro Happold. And in the last 7 years, he has been leading a multidisciplinary team, completing many refurbishment and major intervention projects. And last but not least, Mark Dawson. Mark is an associate in the sustainability team in Buro Happold. He is a chartered engineer, holds an engineering doctorate in environmental technology, is an accredited SIPSI low carbon energy assessor, and a BREEAM accredited professional. Within Buro Happold, Mark leads the company's CIPSI award-winning Building Performance Task Group, and he's the former chair of the CIPSI Energy Performance Group. And in 2019, he was shortlisted as CIPSI Building Performance Engineering of the Year. I think we can now start with our presentations. Just to ask our audience to use the Q&A forum to post any questions, and we'll try to go through most of them at the end of the presentations. So I guess it's over to you, Ewan.
Thank you very much, Anna. First of all, I'm going to talk about the old Wates House and our brief. We had the pleasure of working with the Bartlett back in 2012 when we were appointed to win this, to develop this opportunity. So first of all was all the understanding what the nature of the problem was, and we did that by going back to basics to really try to get under the skin of the Bartlett as one of the world's most forefront of the global architecture education. So the Bartlett School of Architecture is one of the world's most exciting architectural schools in one of its most inspiring cities. Its name stands for provocative ideas, boundary pushing research, and high achieving lecturers and students. To pick up this commission was a huge opportunity and a huge privilege, but also very, very challenging and quite nerve-wracking in many regards, given the high-profile nature of the Bartlett. So this is the original Wates House when it was completed in April 1975, and a view from the northwest. And this is how it was when we picked up the project, or just before we started work in 2014. Not a lot had changed really, other than some large plane trees had grown in the intervening 40 years, but not a lot had really happened to the building in terms of changing the inside or the outside to accommodate the phenomenal growth and success of the school. Inside, we discovered not exactly the most inspiring sequence of spaces, and hopefully some of the audience members today will be familiar with what the building was like back in before we undertook any work. So the studios were quite cramped. Crit spaces were rudimentary, to say the least. Seminar rooms and crit spaces weren't of the highest caliber. Computer clusters had been shoehorned into the building and were landlocked without any light or space or view. And offices were overcrowded, and the workshop had massively outgrown its original restricted footprint. And this was the outside yard space used for making. The library was on the top floor of the building and was actually a rather pleasant space with lots of light and great views, but was quite detached from the rest of the campus. So the overall, the biggest issue was a chronic lack of space and a burgeoning problem that was continuing. So the school had become a victim of its own success, and something fundamentally had to be done about it. In parallel with that, the original building, this is a quote from the original Architects Journal review of the building. I won't read it out, but you can do that at your own leisure. But basically, the building was flawed. It had never really been successful right since its very inception and design and delivery. So our task was really to fulfill the brief, which was to provide better and more space, but also to unlock the problem of the building and how it sat within its context. So the long-term neglect of Wates House, as well as the gradual increase of student numbers over the last 10 years, had worsened the problem of such chronic shortage of accommodation, both in quantity and quality. This has been a recurring criticism by staff, students, visitors, and external examiners for over a decade. So developing the brief, here we have some bar charts which illustrate the existing building and how much of the space of that was allocated to the School of Architecture. And these boxes in white were the remaining parts of the school, or the building rather, which were not allocated to the School of Architecture. So the library was in there, the School of Planning was in there, and there was other areas such as plant and back of house spaces, etc. So the overall building was just over 5,500 square meters. But the Bartlett School of Architecture was only occupying just over half of that area, or around half that area. So our real task was to maximize the amount of space that the existing building, or that site rather, could accommodate. So essentially what we did was double the amount of accommodation for the School of Architecture on the site. The first moves to do that were to relocate the library and the School of Planning out of the building, and they've been rehoused and reprovided for in Central House, of which we did some work to enable. And then fundamentally, we reviewed and added and augmented the composition and types of space within the former Wates House to hugely increase the amount of space allocated to studios, to teaching spaces, to offices for academics and staff, for the workshop, for computers, for shared spaces. So essentially, the School of Architecture gets double the amount of accommodation it originally had, and the overall population The building was originally designed for 330 students and 50 staff to a population of almost 1,000 people, staff and students. So it was a significant undertaking. So how did we do it? So there's a sequence of diagrams here that take us through the process. So we took the existing insular building. You can see here lots of perimeter rooms with internal racetrack circulation, no cross views, very confusing circulation and wayfinding. And we stripped all of that out. We took the roof off, we ripped off the facade of the building, which was not responding very successfully to the surrounding context, and we stripped out the entire interior of the shell of the building to give us a flexible structure that we could then repopulate. We then added as much space as possible in as many dimensions as possible to every part of the building. So every piece of orange space you see on this drawing is new area. So significantly, we took off the existing 5th floor, the roof. We added a new floor and then a floor on top of that. And then we added a stack of accommodation for half of the length of the building to the south, facing Gordon Street, and then to the south of the building, so from basement to 6th floor level. And then these strips of accommodation you see wrapping around the building, we're extending the existing floor plates out to the perimeter of the site boundary to steal back, if you like, or regain 1.5 meters of space right the way around the perimeter over 5 or 6 floors of the building, which doesn't sound like very much, but when it adds up over 6 floors, it equates to over 500 square meters of additional usable accommodation. And all of that allowed us to double the space in the building. Then we re-inhabited this space by reconsidering what type of spaces would be best placed within that framework. So these significant orange blocks here are trying to locate the key spaces at significant parts of the building where they get the best views or best activate the streetscape or views into and out of the building. And then sort of roof terraces and significant views at the top of the building, which get views back across to Euston Station or across the rooftops of Bloomsbury. And then a key move was to add in a new staircase, which unifies and connects every level of the building in a much more transparent, legible, accessible way. We then traced the historic line of the original building envelope with a materiality of timber. And then the extended building line, we framed and articulated in a more robust, timeless masonry skin that started to frame and articulate these key views and moments of the architecture and the spaces within. Some shots of how we actually executed that. So this is a work in progress construction shot midway through. So the roof has been removed, the facade has been removed. You can see we are starting to remove a floor plate here to accommodate the double height exhibition space. So some pretty major structural works were undertaken to the building as well, as you can see in this next view too. So we carved out a large space from the top of the building to the basement of the building to allow new service penetrations to unlock the usage of the building from the rooftop plant right down to the basement, which is the heavily serviced workshop spaces. So some pretty major structural works with a pretty restricted structural frame. I'm going to hand over to Kenichi now, who's going to talk through sustainability and servicing.
Hi. Thanks, Yuan. Following from Yuan's slides there, sustainability strategy was developed having the mindset of retain the concrete structures and therefore reduce a lot of waste generated on site. And also the vehicle movement of construction, reconstructions, and concrete work was reduced significantly. So during the construction period, the vehicle movements were reduced by doing so. And it results in retained embodied carbons within the existing structure and reduce the overall construction carbon footprint as well. Following the sustainability philosophy of lean, mean, green, new facade wrapping this extended major interventions extended body of the building. High performance fabric facade was introduced, and that will reduce the energy waste from the building to atmosphere. Also aiming to bring as much as diffuse natural lights deep into the building as possible. So that was a fine balance in the facade design to achieve. Then the mean side, which is a higher energy efficient active systems, building services, ventilations, heating, cooling systems was chosen for low energy systems, which has high heat recovery air handling units on the both roof and basement plant room, utilizing chilled beam solutions, which I take it for more details later on, and trying to save as much as water, reduce the usage of water. Fittings were introduced all across the building facilities. On the roof, we have a sedum roof for enhanced biodiversity in the middle of the city here. And UCL's one of the sustainability brief is achieving BREEAM Excellent. I've been speaking with all the stakeholders with the Bartlett. We understood the building needs to be future-proofed for many years to come, and also flexible and adapting systems needs to be adaptable system needs to be introduced. Next one, please. This is concept stage sustainability strategies in the diagram. All these features that I've just spoken is kind of shown in here and retained throughout the design to the construction. One thing to note is the UCL has a district heating system. So the building receives a high efficient district heating system to start with. So it's not having any boilers on site and burning gas there. Facade analysis and optimization was carried out throughout scheme stages, scheme design stages. And certain features that Jon was explaining earlier, recessing into to get more shadings, and some of the vertical solar shadings are being introduced in higher levels of the floors. Next one, please. And you can see in the end results in here. North facing has large glazing to get diffuse natural lights as much as possible into the building. Above the entrance, which is west facing there, it's got vertical solar shadings. As the analysis was coming up, this southwest corner was overheating. Other bits, the sixth floor have opaque panels, reducing the glazing to reduce the solar gains into those floors. And overall, those windows were all recessed slightly to get extra shading from the south-facing sun. And services, as I was saying earlier, mechanical systems on air handling unit with heat recovery wheels were introduced. There are 4 air handling units to serve the all floors in here. Choice of the services, environmental control was made onto the chilled beams, which is active chilled beam, which receives air from the air handling unit. This system uses raised chilled water temperature. Rather 6-degree conventional fan units, they use up to 14-degree temperatures, which is higher, achieves higher energy efficiency in chiller system. Together with architectural coordination, this has been selected to incorporate lighting, fire alarms, and other type of sensors. The ventilation mode has been, strategy has been made into the winter time. All this heat recovery ventilation will be running with all windows closed. User can open and close those windows, but strategy is to, in the peak winter time, we close those windows. Same in the peak summertime. Windows should be closed and the cooling should be coming out from the chill beams. But in the mid-seasons, natural ventilation is encouraged as much as possible. Window contactors limits the cooling and heating, shuts cooling and heating when user open the windows. That reduces wasting cooling or heating and escaping out to the atmosphere. Other features, LED lightings were introduced throughout, and the green energy on the PV panels were located on the roof. And this was developed as a diagram scheme stage. All these features of services were integrated into here. And continue to be successfully developed into the construction stage and implemented into the building.
Thanks, Kenichi. I'm going to run through a bit more about how we executed the design, how we continue to collaborate and exchange ideas and develop the design amongst us as a team. So one of the key design moves was to consider how the facade could be redeveloped, and this slide explores different options for how we might retain the facade, replace the facade, or do full replacement. And we tested and explored the different embodied carbon impacts of doing such. In the end, we ultimately removed the majority of the facade other than the structural columns, which did have a bigger carbon impact, but it did mean that we could have a better benefit when we looked at the holistic redesign of the structure and the building as a whole. But by saving the concrete frame, we calculated that we saved 1,700 cubic meters of concrete, which is the equivalent of over 3,000 tons or 260 double-decker buses worth of concrete, with a significant amount of embodied carbon there. And we also significantly improved the building's whole life carbon usage. So on the left of this bar chart graph here, we see how much carbon the building was using in terms of operational carbon, so almost 15,000 tons of CO2 emissions. If we'd done a typical new build, it would be just under 5,000, looking at the embodied energy and the operational carbon. And by removing that amount of embodied carbon in the frame, we made a significant saving to the overall life cycle benefit of the project, which I think is a great achievement for the team and for UCL Estates as a whole, in keeping with sustainability principles. So just moving into how the design was finally executed, we had a few design moves and aspirations that we wanted to imbue the scheme with to transform the identity and the usability and the functionality of the building. So first of these was to create an active, accessible ground floor. So this is a cutaway view looking towards the ground floor. So we can see in blue there the open, publicly accessible parts of the building. So we created a new gallery on the Gordon Street Ensley Gardens corner to activate and display all the great work that the school produces. Created a cafe and a reception point that encourages usability of that space. And around the remainder of the perimeter, you can see seminar rooms and larger exhibition spaces that start to reveal the activity and the usage of the building throughout the day and the academic cycle. And here's how that was executed. So open, welcoming entrance space. It's a bit stark here because this is just freshly on occupation and opening. It was a lot more vibrant, more laterally. We want to create a new shop front for the school. So on the most public facade of the building, previously the entrance to the building was quite secretive and concealed along the south elevation, down a bit of an alleyway. So we wanted to create a much more welcoming, generous, legible entrance with the shop front displaying and celebrating the work of the school, staff and students. And here's how that was developed and finally executed. We wanted to encourage collaboration and connectivity. The wayfinding and movement throughout the building was very problematic in its original incarnation, with two staircases, one of which had a red handrail painted on it and the other which had a blue. And that was how users used to identify in which part of the building they were historically. So we, working with the users and the stakeholders, were very keen to unlock and open up the physical movement through the building. So we upgraded all of the lifts to make them safer and better, but also we made this major move to thread a staircase at the kind of corner, most visible part of the plan and the section to encourage physical movement and views and collaboration, which open up onto these large landings, which are deliberately unprogrammed to create flexible usage for crits or meetings or group work throughout the building. And here's how we executed that. And we worked really hard to make sure this wasn't an enclosed staircase with lobbies and fire doors, etc. We wanted to make sure it was as open and accessible as possible. And that behind the scenes took a lot of work in upgrading the other staircases to make sure that we could keep this one open. We wanted to make the roofscape an interesting part of the building. We wanted to make it respond to the different geometries and constraints of the context. So to the east, the scale of the building is smaller than it is to the west, and it transitions as you rotate around the building from east to west. So we carved out roof terraces to create some moments of breathing space and breakout and sense of the outside world from within the building and looking across the rooftops. We created large frame views, we created these inclined slopes that allowed us to accommodate the PVs that Kenichi mentioned, and also to hide the plant so it's not visible from the street. And here you can see how that roofscape starts to articulate and move around the building and change in scale from Tavistock Street around Ensley Gardens towards the larger Union building on the corner of Gordon Street. We wanted to remember the old. Wates House is a building that had a huge amount of memory and legacy for its previous incarnation of users over 40 years, and we thought it was important to not deny that and in fact to celebrate that. So we carefully kind of peeled away everything we thought was superfluous, and then we kept the old. So we stripped the plaster of the columns and we kept these concrete columns, and we left them as the framework that holds the building, and then we've contrasted and softened that by adding these moments of joinery. So you get the hard and the soft together to reveal the old and celebrate it with the new. And we did that similarly in the staircase. So here's an example of the original staircase with its blue handrail. And this kind of slide to me sums up our whole approach to the building, how we have interconnected and extended with the original and then continued it up to and softened it with our moves of the new. So the hard concrete of the original stair softened by the plywood and timber of the new. We created views out of the building across the city. So there's a nice corner at the corners of the building where that 1.5 meter perimeter, where those two extensions meet on the corners. We created these kind of unexpected and new spaces that with dual aspect that look out across the city, which are quite nice for private working or group work or small meetings or crits. But similarly, we want to create the views into the school from street level. So this is the shop front with an exhibition on, end of year show a couple of years ago. And see how the building responds to its wider context. This is the view from Euston Station, looking across. So it's quite an assertive view, and it marks the entrance, if you like, to the wider Bloomsbury campus from the north. And we want to give the building a whole new identity. So this is our design view as we took the building forward, and here's how it's finally executed. So fairly faithful. And I'm going to hand over now to Mark.
Ewan. So just to clarify, so Buro Happold did the building services, but it was another company called Expedition who did sustainability. The building was finished and handed over December 2016, and then a year later, Buro Happold's sustainability team, who didn't work on the project, were appointed to do the post-occupancy evaluation. So we were appointed in collaboration with Alexi Marmot Associates as well, so to bring a level of independence to the work. And the scope of the post-occupancy study, it was a 2-year project running from looking at 2018 and 2019 performance from these 3 strands. So a function evaluation, so looking at how the building was working for users. So kind of a big part of that was running a user survey, also undertaking walkthrough audits, visual inspections. We undertook a technical evaluation, looking at the energy use, the internal environmental conditions, also air quality, and then a process evaluation. So we looked at how effective the process of actually delivering the project from conception to handover went, and what can be learned that can be fed forward into future projects. So in terms of the existing building, so as has been mentioned, the existing building used a lot of energy. So on the right, you can see a display energy certificate that we were able to find, showing that existing energy use was a G rating, so very high compared to a benchmark. In terms of electricity use, it was using around 180 kilowatt hours per meter squared compared to a CIBSE benchmark of 80. And in terms of heating energy use, it was using around 700 kilowatt hours per meter squared compared to a benchmark of 240. So particularly on that heating side, it was using what's considered far higher than CIBSE benchmarks, and the benchmarks themselves are questioned a lot of the time that they're quite out of date. One of the things that we were able to do was verify that electricity usage based on previous bills from years ago, but we weren't able to find bills to verify the heat consumption. So we had to do a bit of detective work and decide if we think it's a sensible benchmark to be comparing against. And actually what we concluded was that by talking to some of the academics, that the existing building, Wates House, had quite a lot of test cells running. So 8 test cells running 24/7 for kind of large parts of the year, using a lot of gas. So actually that was probably driving up that heating energy benchmark quite a lot, so that's 700. So what we actually thought was, okay, when we think about how the building's performing now and this comparison, let's not compare to the 700 because we don't think it's a fair comparison. Let's compare to that CIBSE benchmark of 240. So when I go forward a few slides, you kind of just have that in your mind, that we're not comparing to the very high baseline. It's a more conservative 240 because there aren't any test cells in the building anymore. And then on to the next slide. There was also some thermal imaging done before the building was refurbished, and there was thermal imaging done afterwards as well. I've just got a shot of the before here. So you can see that there's quite a lot of air leakage from windows, also kind of thermal bridges. The retrofit strategy actually turned to be quite significant, stripping off the fabric entirely. So these images just provide a bit of kind of historic information actually. But yeah, quite evident that the fabric needs improving. In terms of user needs, so yeah, this is the diagram that Hawkins Brown drew right at the beginning of the project through the consultation project. So a lot of users complaining they're too cold, too hot, not enough daylight. Access into the building was a challenge. Ventilation in the workshop was a challenge. And then on top of all this, space was a critical issue, as Ewan mentioned. So the existing building was designed for about 300 to 400 users, and the architecture school had easily grown to over 1,000 by 2000, and still growing. So in terms of the energy analysis, we were quite fortunate to get hold of lots of different energy data sources from lots of different systems. So we had district heating from one system, we had electricity use from another, we also had access to the BMS, and what we were able to do was extract energy data from all the different submeters and basically visualize everything. So visualize kind of heat maps showing time of day energy was being consumed, monthly bar charts, weekly average profiles for summer and winter, and that gave us quite rapidly an understanding of, okay, is the building using energy at an efficient time of the day, and are there any oddities that we need to be looking at? And this is just one slide here because I didn't want to go too far into that, but there was a huge amount of work done here actually working with UCL Estates and their BMS team, so Kendra. So we were basically going through each of the submeters and spotting oddities. So one example was there was a rooftop air handling unit, and all the control kit that we identified was running for some reason between midnight and 2 a.m. every single day. And that had been going on for a period of months, and it hadn't been identified. So through the post-occupancy process of looking through the data, we were able to pinpoint on that issue, and then the university BMS team took that away as an action and corrected it. So that's just kind of one example of the value of looking at the data. If you go to the next slide. And in terms of the electricity use by end use, so this is just an illustration of the energy use on the different electrical submeters. So the two at the top are lighting and power meters, kind of the east and west side of the building, and then we have chiller energy use, and then that meter that I mentioned had kind of some oddities, the rooftop air handling unit panel. So we were going through each of these meters, finding out, okay, what's it consuming? Is it sensible? And how is it comparing to benchmarks? And what we were finding a lot of the time was that the kind of lighting, small power, and the kind of holistic consumption was performing kind of in line with a good practice CIBSE benchmark, which was kind of good for the time. If you go to the next slide. In terms of heat consumption, one thing we found was heating energy use was a lot lower than the good practice benchmark. So actually the building could possibly be using a bit more heating and still be considered good practice. But one of the contributing factors was the level of control on the district heat system. So this graph just shows the annual average heat consumption profile for the year. So you can see quite clearly that heating is being used Monday through to Friday, but very clearly off on weekends and off out of hours. So very, very tightly controlled, as you might want for a typical building. But one thing that we did find through user surveys, and we also had MSc researchers doing some additional studies, was that the building is being used out of hours and it is being used on weekends. So there were some complaints about comfort, particularly during those periods. So actually it warranted, through the post-occupancy study, a need to look at those controls again, and are there kind of periods of the year, say exam times, when people are in the model workshops, where actually the heating should be on for longer periods of time and still be within that CIBSE good practice benchmark. This graph just shows the breakdown of energy use, electricity and heat by all the end uses, expressed as a percentage and per meter squared. So useful source for benchmarking if anyone's doing any research on energy use in buildings. And what it boiled down to was some of these headline figures. So as I mentioned at the start, this figure of the 700 kilowatt hours per meter squared for the heat, we didn't feel was a representative benchmark. So we used the CIBSE benchmark instead for heat, which was 240. But even off that more conservative benchmark, the building was using per meter squared 60% less, which is quite a radical shift from where it was. So really really kind of industry leading performance for a retrofit. And this was per meter squared. I've also put on this graph the Part L performance. So this is the building regulations compliance model that isn't meant to represent reality, but a lot of people often compare what does a Part L result versus actual. So I've just kind of illustrated here that the Part L result was 2.6 times lower than what was expected, but this is very common in the industry for Part L to be 2 to 3 times lower than reality, and that's because the Part L model doesn't include quite a lot of things. So it doesn't include any plug loads, for example. So it's just looking at regulated components like heat and lighting and major plant. And that previous slide was per meter squared, and then this is the same graph again, but in terms of absolute, because as you mentioned, the floor area of the building increased by 40%. So even on absolute terms, so we've got a bigger building that's more heavily serviced, yet it's still consuming 33% less in absolute terms. So again, just stressing that point, that's good positive energy performance coming through. On the user survey, so we did 2 user surveys both years. We also had MSc students writing dissertations who also did their own user surveys as well. So one student looked at air quality in the basements, another looked at thermal comfort in the top floor, so that there's kind of additional survey data out there. But this is just some of the comments that we gathered from our surveys that we undertook. So we did the building use studies survey, the bus survey. So there's obviously a lot more detail, but these are just some of the kind of headlines. So generally speaking, when all the systems are working properly in the building, the users were happy with the ventilation, happy with the lighting, thought the design was functional, kind of good ambience for an architecture school. The staircase in particular kind of came out as a key point that people were visually very happy with. Of course, there's going to be some kind of negative, what I've called constructive comments in here. So these are the actionable things that the university could deal with. So some users were complaining about locked windows when they didn't need to be, lack of plug points, difficulty finding meeting rooms, some spaces being too hot or too cold because the air conditioning system wasn't working properly. So a few things in here that the university could take away and actually actioned and make an improvement on. So this was all useful information for estates. And yeah, so these MSc projects that I mentioned, they're really valuable. So one student looked at thermal comfort in the top floor. So they built a thermal comfort assessment model and did surveys and measurements. And their study was essentially showing there were some thermal discomfort issues on weekends when the chilled beams were switched off. So we raised that to UCL Estates and had a meeting about it, agreed some actions. And then the second student looked at air quality in the workshop areas, measuring PM10, PM2.5 in all the different types of workshop spaces again. And one thing they found was that the air quality levels were exceeding levels that we would like on weekends when some students are in, and the extract systems weren't always on. And through that process, actually a change got made to the design where some interlock controls were fitted to the workshop equipment, which meant that students could no longer switch on the equipment unless the extract was switched on. So that was a design intervention that was actually informed by some MSc research. That was kind of really positive. And I've just put this on the screen as well. So one of the students also produced some workshop guidelines around air quality and safe working, which I thought is, today's world with COVID is kind of more important. Actually, these sorts of user-focused guidelines come through. And we also ran a lessons learnt workshop. So you can see the people on the chairs are at the front are Alexi Marmot Associates. So we facilitated a workshop where we brought together members of the design team, the construction team, the facilities management team, some end users, the dean for the Bartlett was there, and some department leads for the workshops. And we were basically going through every single REBA stage one by one. So, okay, REBA stage one, what was the brief? Has the building met that brief? What was the budget? Was it the right budget? And then kind of going through the detail of like stages 2 and 3. So how well did the design team come together, coordinating each other's work? Could stakeholders have been brought in earlier to inform some discussions? How smooth was that handover on the contractor side? So there's this big workshop that was done that was really valuable actually, and produced a lot of lessons. So on the next slide, I've just put a few of the outcomes. So one of the things in particular was that on the Hawkins Brown side, Ewan didn't mention it, but they basically had a lead architect and then they had the deputy architect. And when the contractors came on board, that deputy architect actually worked for the contractor. So that enabled the contractor to get up to speed very rapidly on the design, all the complications of the existing building, but also having someone internally on the contractor side in charge of preserving design quality. So that was deemed as a really kind of helpful function for the contractor to enable them to deliver a building meeting the user needs. Also, this mix of kind of modern and raw finishes, the users are saying gave this really good feel of an architecture school. So it was a good kind of palette to take forward for future designs. I've mentioned the energy performance already. Seasonal commissioning, so Kenichi didn't talk about that, but Buro Happold came in and did some seasonal commissioning as well, because there are quite a few snagging issues in the first year that needed some attention, and the value gain from the MSCs was really useful. So I'd encourage anyone doing MSCs on the line to do post-occupancy MSCs and work with companies like us to get it done. And then just on the right, I've just got some closing remarks from the dean. So he was quite happy. It was a long project. He'd put a lot of blood, sweat and tears into it, I'm sure, over kind of 10, 20 years, probably longer. But he was quite happy with the overall result, saying, set a good standard for architecture schools going forward. And off the back of this work, we actually worked with UCL Estates team to take our methodology and push it forward into a new set of post-occupancy guidelines for UCL. So now actually, if you go online, there's something called the post-project review guidelines. And if you go to the next slides, so basically all projects now completed will go through the process evaluation, so the lessons learned workshop, with some staff surveys, and then projects above a certain size or criticality will also undertake the function evaluation with the full user survey and the technical evaluation, the full POE. So UCL have committed to doing these post-occupancy studies on all projects now in a standardized way. And on the next slide, I'm just showing a couple of checklists that you can find in those standards. So it gives this is just showing a checklist for POE activity. So it's not just looking at energy and comfort, it's looking right through back at design intent and design strategy, construction, procurement. And then again on the next slides, it's just some examples of some templates that the POE consultant would be using. So questionnaires for staff and students. And there's also a lessons learned database, which gets populated as part of the POE. And UCL, on the next slide, have put a team around this as well. So David Stevens, who's the assistant director, in UCL, he's pulled together this transition engineering team. So working alongside sustainability and health and safety, there's now this new transition team, which is the custodian of all the lessons learned being collated across all these projects, and they're sitting in on project inception meetings and soft landings meetings to make sure that all the lessons that will now be gathered from these post-occupancy projects are being pushed through to new projects. And then on the final slide, I've just illustrated this soft landings wheel again. So if anyone's not familiar with soft landings, it sits alongside post-occupancy valuation, with post-occupancy being kind of the final piece of that puzzle. But it's basically just kind of encouraging this extra layer of stakeholder engagement, briefing, engagement early with end users and facilities, to minimize the number of pitfalls that you have on projects, and learn from the past, make future projects more successful. So 22 Gordon Street is one project in a much larger rollout plan, expanding the Bloomsbury campus for UCL. So hopefully this won't be the last time you hear a presentation about POE. That's it from me. Thank you.
Great, thank you, Mark. And that wraps up our presentation. Thank you very much indeed, everybody, for listening.
Thank you so much, Ewan, Kenichi and Mark. That was an excellent presentation. And I have to say, I joined the Bartlett back in 2006 to do my master's. And those first pictures you showed of the cram studio space really brought back the memories. So I'd like to thank you for the amazing work you've done with the refurbishment. And it really gave new life to the building. And it was really nice to see the very detailed thought process behind every design decision, and how you've respected the character and its history while giving new life to the building. And I also like how the POE findings are fitting into the whole process. So thank you for the fantastic presentation. We now have a little over 10 minutes until the end of the session. So I'd like to go through the questions quickly. We have a few questions in the Q&A. So I'll read them out. If you please try to give concise answers to ensure that we try to answer as many as possible. So the first question is from Theodoros Charitidis. Are the windows fixed?
No, is a simple and short answer. They allow some opening in the main majority of the studios and office spaces, but I think they have been locked on occasions by the estates management staff, which, as Kenichi and Mark mentioned, created some feedback. But the principle is that they can be opened and managed by the users themselves.
Thank you. Next, the questions from Michael Corcoran. From an environmental design standpoint, what is the justification of window area below table height? Don't know.
Do you want to take that one? I mean, I can answer architecturally, but doesn't really answer your question. I mean, the furniture is not against windows, and we wanted to fenestrate, maximize the daylight and views in and out of the building. So that's why the buildings are the windows are floor to ceiling primarily, and it also improves the composition of the fenestration arrangement around the overall elevation design. So that was how we developed it architecturally.
Yeah, so from windows lower bit, we chose the performance of the glazing. So although it is larger by doing that all the way down, we can still manage that within the performance that we specify within facade. I think it gives more of the architectural view of the city a lot better open to that way.
Mm-hmm. That's great. And in terms of resilience, what is the present heat and fuel? If gas, is there a plan in place for conversion to some alternative strategy?
Heating is provided from district heating systems in UCL. UCL has a large network of district heating network coming from the main campus and 4 different boiler plants. They are gas and gas boilers, CHP engines, a mix of different technologies used, and I think there are plans to continue to improve that systems in a central engineering point of view.
Great, thank you. The next question is from Alan West. Did the frame or substructure require reinforcement or intervention for the additional floors at roof?
A great question, Alan. We couldn't do anything with the substructure because it's a raft foundation of about 750 mil thick, so we couldn't modify that in any way because it would have created more problems than it would have solved. But we did have to strengthen some of the basement superstructure. We also had restrictions on how much additional load we could put onto the existing superstructure and substructure, which made it challenging when the planners insisted on a masonry facade. So we had quite a few challenges there that we had to negotiate quite carefully in how we balanced the additional weight in terms of loadings and new floors against the overall bigger picture. So the new floors in the upper levels are lightweight, so they're steel and timber constructed with light gauge steel decks and concrete slab infill. So we were constantly evolving and testing and finding the optimal balance of between space, structure, loading, and overall architectural solution. So that took a lot of testing and exploration.
Great, thank you for this. A question from Francesco Pomponi. Wonderful presentation and stunning work. Was the SIPSI TM54 used in conjunction with Part L to have a more realistic estimate of the as designed in order to compare it with the as built and investigate any energy performance gap?
So whilst I wasn't in the design team, I can answer this. So the answer, I think, is no. I don't believe there was a TM54 done. However, what we were able to find was that back in 2011, so before the design team as it is now came forward, that there was actually a study done by Hilson Moran looking at the potential energy reduction that the building could achieve. So they actually produced an operational energy study back then, which was showing energy savings in the order of 60 to 62% actually. Which is what it turned out to be. The system strategy was quite different in their design versus what actually went forward, but it showed even back then there were operational energy studies being done and the potential of what the building could achieve. So actually, in terms of that performance gap, actually, this historic study was actually quite accurate in terms of showing the potential for where you could get this building.
Great, thank you. The next two questions are posed by Edward Murphy. Was a dynamic thermal simulation model developed for the design, and would this not have been a better benchmark to use than for power and heat?
So again, I'll try and answer it. So the Part L modelling was done through dynamic simulation. However, as I mentioned, it would have been done following the building regulations compliance method, which isn't representative of reality. So you're using standard templates for when things come on and off, and you're excluding quite a lot of end uses. So on the heating and cooling side, it's more these standard templates. So if a building is operated under the exact conditions as those templates on off at those times, then yes, it can be used as a benchmark. But actually, I think what we learned through the POE was that the building does get used for extended occupancy periods, so it wasn't really a fair comparison. And I mean, to hammer home the point, Part L should never be used as a comparison between reality.
Yeah, architects tend to extend hours, I guess. And another question: how is loss of single-use offices managed with senior staff?
In a word, carefully. We had lots and lots of really good and positive engagement with the users, and we in fact had a project champion and a design champion from the Bartlett and the wider faculty, and they were fantastic. So it was Kevin Jones and Mark Smout were fantastic advocates for the academic community and for us to explore and develop different models and a range of solutions for academic offices. And in the end, there are still some private single occupancy academic offices, but there's more of a balance now.
One question from Jim Kinneborough: is there carbon dioxide monitoring?
Original CO2 monitoring isn't there. We've got the occupants ventilation, so the PIR would together with the lighting PIR sensors that operates the beam systems, two beam systems.
Yeah, so it's not there, but the two MSc students that we had did monitor CO2 as part of their project actually. So there's some data, but actually as part of the lessons learned, we actually recommend that all projects going forward do have CO2 sensing, so it adds that additionality in terms of control.
Great. And one question from you, Manga Karval. Was sound from the busy roads around Houston an issue? And if yes, how was it addressed?
So it was an issue, and it was reviewed and assessed. As in a way, that's another reason for upgrading the entire fabric of the building to improve not only its thermal and performance, but also its acoustic performance. So we did some testing and some analysis of the existing context, and that informed values that we had to design into the window and facade performance.
Great. Anissa Ben Yahmed is asking, what material was used for insulation?
Primarily, it's mineral wool, so rock wool, but there is some rigid insulation in areas such as the roof as well. So it's a bit of a hybrid solution, but it's primarily a mineral wool.
And there are two questions there that I think are interconnected. Theodore is asking, what was the main reason of stripping out everything and not rebuilding it, mainly cost or waste? And Alan is asking, architecturally, do you think the design solution responding to the brief would have been very different without retaining the frame? What are the lessons learned, and maybe lots?
I'll start with the first one from Theodoros. It's a really good question. There are three main reasons for why we did what we did by retaining the building. One is program. It was like 12 months quicker to build, to retain the majority of the frame and then remove and retrofit. Two was cost, and so the program was important because UCL Estates had acquired a temporary decant property off-site at Hampstead Road, which some of you may recall. So, but that was only available for 2 years because it was blighted by HS2 and has since been demolished. So we had a very finite program timescale that we had to work within. So the fact that retaining the frame accelerated the construction process was a critical driver. It was also approximately £10 million cheaper than a full demolition and rebuild, because we're retaining that much of the frame and it's quicker to build. So that was a significant driver. Thirdly, because of the existing building has quite low floor to ceiling heights for an academic building. It's about 3.25 floor to floor from memory, particularly on the upper floors. It's more generous from ground floor to first floor and basement to first. But if we were to put back an equivalent building on the same site now, you'd probably be looking at minimum 4 meters floor to floor. And overall, over the scale of the massing that we were able to agree and secure with Camden Local Authority, we would probably have achieved less overall usable area. So that was another driver for retaining the existing frame. And then lastly, there's obviously the sustainability and environmental benefits of recycling and retrofitting and upgrading the fabric.
Thank you. So I think there is a question from Bill Borders, how much the cost relates to a new building? I think you've answered that already. And there is also another question about the performance gap, which I believe you also addressed. There are a few more questions, but I'm afraid we are mindful of the time. So if you have any additional questions, I believe there is going to be a message as you leave the Zoom meeting, and you feel free to email us, the organizers, and we will send any additional questions you might have to our speakers. So I'd like to give a virtual round of applause to our excellent speakers. Thank you again so much. And thanks for everyone, to everyone who joined. Our next webinar is going to be on Friday, the 27th of November, same time, and we'll have AHMM Architects presenting the White Collar Factory. So again, you're very welcome to join us. So thank you so much for the excellent presentation, and to our audience for their great questions. See you all very soon.